This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. As a software engineer, chances are you've crossed paths with MongoDB at some point, whether you're building an app for millions of users or just figuring out a side hustle. As the most popular non-relational database, MongoDB is intuitive and incredibly easy for development teams to use. Now with MongoDB Atlas, you can take advantage of MongoDB's flexible document data model as a fully automated cloud service. MongoDB Atlas handles all the costly database operations and admin tasks you'd rather not spend time on, like security, high availability, data recovery, monitoring, and elastic scaling. Try MongoDB Atlas for free today. Visit mongodb.com/cloud to learn more.
Hello everyone, this is Felienne for Software Engineering Radio. Today with me on the show I have Margaret Burnett. Margaret Burnett is an OSU Distinguished Professor at Oregon State University. She was the principal architect of the Forms tree and FAR visual programming languages, and she pioneered the use of information foraging theory in the domain of software debugging. Burnett is an ACM Fellow and leads the team that created Gendermag, a software inspection process that uncovers gender inclusiveness issues in software from spreadsheets to programming environments. Welcome to the show, Margaret.
Oh, thank you so much. I'm glad to be here.
So recently we had a show 367, about debugging, where we talked about all sorts of different bugs and how to approach them. But today we're going to talk about a really different type of bug, the inclusivity bug. Can you explain us what that is?
Right. So it turns out that a lot of different people have different cognitive problem-solving styles. And so when they go about trying to solve a problem collaboratively with a computer for one thing or another, they have different ways of going about trying to get it solved. Well, it turns out that software doesn't do a great job of supporting a lot of those cognitive styles, but they're still very good ones. There's nothing wrong with them. And so we call those inclusivity bugs. They're inclusivity problems, but they're more than problems, they're bugs, because they're at the granularity of bugs, because what it means is there's some feature within the software that has barriers in it. And so what we have to do is find those barriers and take them down one at a time. It's not a matter of coming up with entirely different versions of software, because that's way too big a granularity.
So can you maybe give an example of an inclusivity bug?
I certainly can. So everything that I work on in this area is actually cognitive. And so individuals have huge differences in their cognitive styles, but some of these cluster into various groups, such as gendered groups. So one example is information processing style. So imagine some individual, they're sitting in front of a computer and they're trying to solve a problem, but they get stuck because the problem is hard. And so in that situation, most people feel like they need more information. But there's more than one style of gathering that information. So one style is called the selective style. In that style, somebody gathers a teeny little bit of information and they know it's not enough, but that's okay. They want to try it out immediately to see where it goes. So, and then they gather another teeny little bit of information, try that out too, then a third teeny bit of information, and then they see, okay, I'm going down the wrong path. Backtrack. That style is the style that most software expects. But there are other styles. For example, one style is people who really want to get their head around a problem, gather plenty of information before they start just blundering forward. So that's called the comprehensive style. So the first style, the little one that I mentioned, is very, very iterative. Gather, do, backtrack. The other style is much more bursty. Gather, do, gather, do. Most software does not support that style.
Yeah, because it seems that iterative style is something that I would say naturally fits with programming. Like, oh, you change a little bit and then you immediately test. But that's maybe an inclusivity bug in me, because that's the culture we have and the type of things that we support.
That's right.
Are there other styles besides those two styles?
Yes. So information, we have, you can imagine it as types and values. So we have the information processing style or type, and then there are two values, the iterative style and then the more comprehensive style. We have four other facets that we work with a lot. One of them is somebody's motivations for working with the software. So it's not how motivated they are, it's what motivates them to be working on it. Some people are much more task motivated, so there is some problem that's interesting and important to them, and that's what they want to spend their time thinking about, not the tool that surrounds it. Other people are much more tech for its own sake motivated, which is, so yeah, I brought this task, but look at this cool new feature I can play with. So that's another motivations is the type, and then those two different versions of it are the values. The third one is risk, basically attitude toward risk in technology. So some people are much more interested and willing to take risks in the way they use technology, and others are much more risk averse in the way they use technology. And just like all these others, there's no better or worse, just different. A fourth one is computer self-efficacy. So this is somebody's particular prediction of how well they personally will do for the upcoming situation at hand on the computer. And so there are some people who have lower computer self-efficacy than, say, their peer group, and it doesn't matter what job title you're talking about because it's always relative to your peer group. And the fifth one is people's learning styles as it relates to technology. So there's more than one way of going about learning some incremental new feature or some entirely new product. And here again, we have inclusivity bugs in the software.
So there's all of these different styles, but what is the reason that we have these bugs, these inclusivity bugs?
It's an interesting question. Probably a lot of reasons, but probably if you go back in history, the first and most important reason is that most of the people who developed the software were men. And this has, of course, been true for decades. And so, when a software developer develops software, they make all these micro decisions at every second. And what they're doing is they're deciding how the software should operate in a way that feels intuitively good to them because they're doing the best job they can do. But of course, that's just one human being. But the trouble is, historically, the software has been built not only by just men, but often by just men who are a whole lot like each other. College educated in particular majors, in particular countries, at particular education levels. So a very undiverse group of problem solvers. And so then, once those sort of design patterns were present in software, they became part of history and part of inertia, and sort of design, this is the way you solve that kind of problem. And so they became sort of embedded in the way we think software should be.
Yeah, can we think of a more concrete example of a software, maybe the name of a certain package that really supports a selective style but not a comprehensive style?
Oh, we sure can. So I'm not going to name a product, but there is a very common type of product, spreadsheets. Probably all of our listeners have used spreadsheets before. Probably everybody in the whole world has used spreadsheets. Well, not everybody, but anyway. Okay, so imagine yourself trying to fix a spreadsheet that's not working right. If you're an academic, imagine yourself trying to work a really difficult budget out. It's your grant budget. You're required to use some really ugly organizational spreadsheet that everybody in your university uses maybe to sort these out. Or if you're working for a company, you're trying to figure out, your department's budget, and it's a mess. There are big formulas and small formulas and lots of them with all these interrelationships, and it's not working. So your job, you've got to fix it. So how do you do that? Well, if you're the iterative style that we talked about before, also called the selective style, the software, most of the spreadsheets were built exactly for you. You are a happy camper. So let's begin. Here's this spreadsheet. You put your cursor on some cell that seems to have a suspicious value, and you see the formula, and it's long. And you look at it and you think, I'm not really sure I believe that the parentheses are right in this, so I'm gonna just fiddle with these a little bit and see if that makes a difference. So you do. So far, so good. And then you're thinking, well, I'm going to try that on another one too, because of course these need to be consistent. And so in order to pick your next one, you can put your cursor usually in the formula bar and it lights up other cells that could have contributed to that. So it's really helping you pick out your next little drip of information. Or there are even features you can turn on that get dependency arrows going for you, all kinds of stuff to help you with this task in this way. So you pick out your next one and put your cursor there on that cell, and there's the formula. You say, okay, I'm going to change those parentheses the same way. So you do that, and at that point, you see the values and you realize, I don't really think that was the right thing after all. Backtrack, and try another path. Perfect for the iterative style. And that iterative style, of course, reminds us somewhat of very incremental testing, which is, of course, very well respected in software engineering. One way of going about finding errors is testing. Another very well respected style is called code inspection in traditional software engineering. So with spreadsheets, let's call that formula inspection. Obviously, a respectable tradition, and this is one that's much more aligned with the comprehensive problem-solving style. So let's try doing that in a spreadsheet. Put your cursor on a cell, look up the formula bar, there's a formula, memorize it please. Now put your cursor somewhere else, there's another formula, memorize that too. Now put your cursor somewhere else, there's another formula, memorize that 3. Okay, so this is horrible, right? Nobody is going to do this. But in some spreadsheets, there's a little known possibility that some people know about. Sometimes it's hard to get to, but sometimes you can, called the formulas view. In that view, of course you don't get to see the values anymore, but instead in all the cells what you see is formulas. So this you would think, okay, this is going to be the right thing for formula inspection. But there's a problem. The column widths are all wrong. And furthermore, it's not really obvious what all these column widths should be because you have short formulas and you have long formulas, and these long ones are like super long. So now you need to spend some time rearranging your column widths to do the best you can to get these formulas on the screen. At this point, you've spent a lot of time messing around. Still, you aren't at the point where you get to actually problem solve the problem you came here to do. Finally, though, you get them all arranged. You start looking at these formulas. And now, since you've got all of them, you start to see some inconsistencies in what seems to be the underlying assumptions. One set of the spreadsheet has formulas, that seem to be based on one set of assumptions, and then another one, a slightly different set of assumptions. So you realize that that's what the problem is. That's why things in the spreadsheet are inconsistent. You fix them. You fix a batch of these, and now you're ready to go back to the values view. Okay, fine. You go back. But yeah, you've got your values, but the column widths are all wrong because the system just made you change them all. So now you have to put them all back. So what all of this amounts to is a huge cognitive tax that the comprehensive problem solver had to deal with. But now that we know that, now that we can find it by thinking about cognitive styles, the fix wouldn't be that tough. I mean, for example, getting over to the formulas view would be a lot faster and more discoverable. And once over there, maybe the column widths could just shrink wrap themselves around the formulas. And then when you went back to the values view, the column widths could just automatically restore themselves. So it's not that hard a bug to fix. The tricky thing was knowing what to look for to find it.
Yeah, and in that sense, these bugs might be the same as regular bugs, where
Yes.
often the hard part is finding the bugs rather than solving the bugs.
Yes.
So, of course, if we think about bugs, we also think about testing, unit testing, integration testing.
Mm-hmm.
Is this a thing that can be done for inclusivity bugs?
Well, so maybe. There is you can imagine testing methodologies that might work for it in some sense, but there isn't really any research that's tried to explore that very far yet. Instead, what we have is an inspection method that people can use to try to find this kind of bug, which I think you're going to ask me about real soon now.
Yeah, that's true. We're going to go for a few other things first,
Okay.
but we're definitely going to get to that investigation method. So, Would it help if we have more women developers on teams? Sometimes, of course, people say, we need more women because we will have diversity. But of course, it isn't necessarily true that women are aware of these things. Do you think that it will be a good fix to have more diversity on teams?
Well, it's certainly not a bad idea for many, many reasons. But it's not an automatic fix either. Because the trouble is, there's all this inertia, all this history about the way software is and the design patterns that I referred to before. And so just adding more women to a team wouldn't probably be enough because of all of that history. It would take a real outside-the-box thinker to say, you know what, we have to just ignore all of that history, go back to square one, and really rethink what it would be like. But the good thing is, once you have a method that tells you what to look for, it's much easier for both men and women to start spotting these things. So, yes, good thing to have more diversity on team. No, not a panacea.
So we talked about these different types of styles, information finding style, but also motivation and risk aversion. But we haven't really talked about that in the context of gender. So how do women do on all of these different scales?
Okay, so it's a great question. First of all, in some sense, it doesn't have to do with gender or gender identification at all. But statistically, it does. So to illustrate what I mean, imagine a graph in your head, a bar graph in which the y-axis is a count of number of people at certain heights, and the x-axis is just different heights, 5'3", 5'4", 5'5", all the way up to, 7'10". So on that graph, if you were to plot men and women, what you would find is two bell curves. And within the width of these bell curves would be very wide. You'd have lots and lots and lots of individual differences between one of those genders and between the other gender. But you'd also see some skews, with more of the women being on the short side and more of the men being on the tall side. So that's what a height graph would look like. A weight graph would look like the same thing. And it turns out that a cognitive styles graph also would look the same way. So let's go back to the let's go to let's make it the weight graph. With the weight graph, supposing that only the heavy half of the graph were supported. You have to weigh a certain amount to keep the boat from flying up into the air or something, okay? So what that would say is many of the women would be excluded from being able to use that boat, but only a few of men would be excluded. So it's all about individual differences, but it's also about these statistical clusterings. So then if we just paint that same graph in our heads, but realize that now it's about cognitive styles instead of about height or weight, the graphs look the same. And then we say, well, let's just draw a line right down the middle of it. And let's say software supports only 1/2. Well, guess what? It does. And so what that says is that software is supporting a reasonably large fraction of the men and a very small fraction of the women.
And then I guess we know which of the styles fit more statistically often with women than with men.
Yes, I need to interject something too. There are more than two kinds of gender identifications, but the statistics that we have so far are only on the two that are the best known, the men and the women. So I'm not meaning to imply that there are only two, but only that much of the data that's available so far is only on those two.
Yeah, that's very good to point that out. So for the styles, for example, the selective style and the comprehensive style, which is the manly style and which is the female style?
Yeah, so men are much more likely to have the selective or the iterative style, and women are much more likely to have the comprehensive style.
And what about the other things? The risk aversion? I guess men are more risky and women are more risk averse?
That's right. But this also gives me an opportunity to point out that these situations are very fluid. And so, for example, if imagining this graph once again in your head, this same graph with the two bell curves, supposing that the setup is you're programming a little game for your kid, okay? The graph is going to be the same but squished because people are going to care less about risk. So although the women are going to be somewhat more risk averse statistically than the men, there's not going to be a huge difference in that situation. On the other hand, let's say what they're doing is programming security software. Now that graph is a huge shift in the other direction, also squished, but because now everybody is a lot more risk averse. And so the long and the short of it is, because not only somebody's preferred cognitive style, but also the situation they're in right now affects things. This is another reason to say we can't think about this statically and say, oh, we just need to classify people and then we know what version they need. They need to be able to adapt to the moment that they're in. And so that's why we have to take down barriers so that any individual can be doing things in the way that's right for the problem they have and the situation they have, rather than trying to put people into bins and classify them into it.
And we also talked about motivation as one of the things where people differ. So how is that in terms of gender?
Okay, so here I always pronounce it motivations so that people don't confuse it with how motivated somebody is, but rather what is motivating them. It's much more usual for women to be motivated by the problem they came to the computer with, and men to have a stronger motivation around tech as a toy. And so, for example, and this is true in any profession. So let's take, for example, software developers. So a woman software developer might be very excited about the software she's developing, and she's trying to find some bugs in it and add stuff to it. And so she's very excited about technology. It's not as though she doesn't like technology. I mean, that's her life. She's creating it. But what she's not excited about is fiddling around with the tools around the edges. What she is excited about is focusing on what she wanted to focus on. On the other hand, a man software developer might be, of course, very excited about the software development they came there to do, but just as excited to land in, a new feature that they hadn't seen before. So much so that they could even get a little distracted by fiddling around with this new feature. So they're happy to sort of think for a while at the toy level, whereas statistically more women would be more frustrated by having to be distracted by the tool around the edges.
And again, very much like the iterative style, we also see that as true computing or true programming. I think this is also true where, as a community, we very much value people that love the tools, that love, I'm in love with Ruby or with Python. We value that more than, I really want to build this app for, people with Alzheimer's or something.
Yeah, I know. And that is something that has been true, and it's just because of history. And so humans have this very strong built-in tendency to prefer people just like them. So if you get some, I love tech as a toy people in at the beginning, then who do they hire? People just like them, under the mindset of, I'll know it when I see it, and I'll know the perfect person because they'll be just like me. And so this is why the community now has developed these values of what makes a good programmer. It's just history. But it's not correct that those people necessarily make better programmers. What really makes better programmers is a diverse team that thinks about things in a lot of different ways. And so by this, I don't just mean different appearances or different ethnicities, but also different mindsets. Cognitive diversity is the very reason why businesses are working so hard to bring in diverse workforces. It's not always about good citizenship. More often, it's about the bottom line, because science has shown that supporting a diversity of mindsets on a team, including a software team, makes for better products, and that's what they want. So if we don't fix these inclusivity bugs, we're actually hampering what's going to come out of the software we're building.
So you already mentioned science has shown that this works.
Yeah.
Do you have some pointers to that? We can, of course, link to papers and blog posts in the show notes. Mm-hmm. Do you know some of the work that has been done on that?
Yeah, I can tell you some of the top researchers. So the diversity points that I just made, Scott Page is one of the top researchers in that area, and he has his entire career has been about understanding the effects of diversity. So you can certainly look him up. In terms of the 5 facets that I've talked to you about, the 5 cognitive styles, things like motivations and information processing style and that sort of thing, the way we started this work is we read from 5 different fields, trying to find the really foundational research about how people problem solve. And then what we did is take some of that into the lab to see whether those differences that had been found in fields like education and psychology and feminist literature and certain business academic subfields, see how these things would play out in the usage of software itself. So let's see here. In the computer self-efficacy area, the pioneer there from psychology was Bandura. And let's see here, the information processing style. A lot of the pioneering work there came from Joan Myers-Levy. Let's see here. I don't think I can call the other authors to mind, but of course my papers on the subject all reference these older works because that's what we built on.
Yeah, and we'll make sure that we put links to those papers in the show notes so people can check it out in more detail if they want to.
Great.
So we talked about different styles and different programs, how they embody styles, but can we just teach people to learn a different style? I mean, if people are of the comprehensive style and all the software is the iterative style, why don't we adapt to people? Is this possible?
It is possible. People can learn. But the trouble is, well, there are so many troubles with it, I don't know where to begin. The first one is there's a huge cognitive tax in asking people to suddenly start reasoning a different way. So why are we imposing that tax? The purpose behind a lot of software is to make people more productive, not less. So why are we saying, oh, we have a great idea, we're going to add cognitive burden to everybody so that we can make them just like us? So bad idea. Second point, doing that is actually saying we want software that stamps out cognitive diversity. Really? I mean, all of business wants more cognitive diversity, not less. And thirdly, software is not, even if we wanted to stamp out cognitive diversity, some piece of software is not the right one to decide what kind of cognitive thoughts people should be having. I mean, if we really, really, really wanted that, which we don't, we'd want someone qualified saying, well, what is the ideal cognitive style? Not some piece of software that somebody originally threw together and then everybody else decided to find the state of the art.
Yeah, so even if we want to go that way, we should think about what is the best way to do it and not accidentally encode who is in software now.
Right, exactly. And furthermore, we don't want to go there because cognitive diversity is so valuable, so important to all of society and all of business and all of productivity that we absolutely don't want to go that way.
So we don't want to go that way. We do want to go the way of understanding these different cognitive styles and especially understanding how we can make software better with that knowledge. So for that, you have developed the Gendermag Method that we will spend the rest of the show talking about. So what is this Gendermag Method?
Okay, so Gendermag stands for Gender Inclusiveness Magnifier. And it all started with the gender research that my students and I were doing a long time ago. Eventually, we did build this method, and I need to also emphasize that at this point, the team is co-led by Anita Sarma and me, so it's not just my method. Anyway, so Gendermag is an inspection method to be used by software developers, software managers, user experience people, whoever it is that is empowered to shape the software that they're building. And they use it as early as they possibly can on their own software that they're creating. It can even be at the level of sketches, you know, just a PowerPoint prototype even that they can walk through. Anything that is walkable, throughable from the perspective of some user. And so they use the method, which is a combination of some research-based personas integrated into a specialization of something called a cognitive walkthrough, which gives them the process. And using this method, they walk through a scenario of their own choosing or a use case. So let's say, for example, if they were building a spreadsheet system, maybe the scenario would be exactly this little story we told earlier. You know, this persona wants to solve this hairy, awful problem in their spreadsheet formulas. And, you know, so here's what the spreadsheet looks like, and here's what the system looks like. You know, what's the first thing we want them to click on? And then we decide whether or not they'll do that based on their cognitive styles.
So you mentioned two things in your explanation. The walkthrough, which we've covered briefly, but you also mentioned that there are personas.
Yes.
What is a persona, and which are the ones you have in Gendermag?
Okay, so a persona is a fake person. It almost always comes with a picture, a name, some demographic information, and in our case, 5 cognitive styles. And so we have 3 of these personas. We have Abby, who represents the cognitive styles some cognitive styles that are very common among women. We have Tim, who represents the same types but different values of these cognitive styles that are very common among men. And then we have the Pats, who bring up not only middle values but also some that aren't covered at sort of either end of the spectrum. And the reason that we have only 3 and not lots and lots and lots of them is that if we had a huge number of them, the method wouldn't be practical. And so our thinking was, if we can sort of flatten our cognitive styles down to a linear scale, then if we can cover both ends of those scales and one in the middle, then we will have in some way covered the entire scale. Because if you can make things work for both Abby and Tim and even the Pats, then you've done a pretty good job because,
Yeah, so it isn't one persona for all of the 5 characteristics on both sides.
That's right.
It's trying to group this canonical female behavior and canonical male behavior and middle behavior.
Maybe. I wouldn't say canonical. It's more along the lines of, we know that this, so let me separate my personas in half now. So there's a top half and a bottom half. So we'll take Abby. Abby's bottom half is this bunch of values that are very common in women for these 5 cognitive styles, and these can't be changed. So for example, Abby is risk averse with technologies because she is a very busy person and she just really doesn't have time to fiddle around with avenues that might not get her anywhere. So that's Abby, the bottom half of her. The top half is entirely customizable. So Abby can be any gender. We can use any picture. Abby can be short for Abigail or Abhishek or Abner, anything. She can, or he, or any pronoun in fact, can live in any location, have any job title, any age, any educational background, any hobbies. All of these things are meant to target the product you're interested in. So for example, if it's spreadsheets, maybe you want Abby to be an accountant. If it's
Scratch, it might be children.
It might be children, exactly. So that's what you do with the top half. Anyway, the bottom half, then, those are entirely based on research. The top half are flexible. Did I answer what you just asked, though?
Yeah, I asked if those 3 personas, they try to, it was mainly rephrasing, I think.
Yeah.
That they try to cover the entire spectrum more towards the things we typically associate with women and more towards what we associate with men, and then there's the Pats in the middle.
Right. But I do want to drop the word typical and the word canonical. So it represents people who are at those 3 points.
Yeah.
But I wouldn't go so far as to say typical. It's more like Pat and Abby and Tim are like guards at various places, that somebody could be. And so by having guards spaced every so often, then you can rest fairly assured that they're going to be able to catch stuff that would be between them as well.
Yeah, so if we think about those 2 bell curves that we talked about earlier in the episode, one is at the one end, and the other is at the other end, so then we cover all of the areas under the both of the bell curves.
Perfect. Yes, thank you for saying it so well.
That's I'm just rephrasing what you were saying. So we have these 3 personas. Mm-hmm. How will they exactly help us to evaluate? So you talked about a walkthrough, but can we get that in more detail?
Yes, we can. Okay, so back to the spreadsheet scenario. Abby wants to solve this hairy, awful spreadsheet that's in front of her. And so we asked the developers, what did you want her to click on first? And so the developers say, we want her to click on this cell and then look at the thing in the formula bar. So then we ask ourselves, will Abby do that? Yes, no, maybe, and why? And so in asking why, we're directing all the people in the room to dig into that persona that should be sitting there in front of them, look at those cognitive styles, and think about whether Abby would actually want to do that. My thought is, yes, of course she would at this point, because she's very task motivated, which has to do with her motivations. And she's a comprehensive information processor, so the very first thing she wants is a formula. Okay, so far so good. And if we were doing this same walkthrough at another time in another meeting with Tim, we'd probably also have a yes so far. So then after we've answered the question, we write everything down, and then we make her do it. So then, of course, there's no real Abby, but we click there and see what Abby would see. And then we say, will Abby feel like she's making progress toward her goal? Yes, no, maybe, and why? Again, going back to the cognitive styles. So far so good in my opinion. And so what I think is, yes, everybody in the room would say so far so good. But the next step is where we'd start to get in trouble. So at this point, the developers might say, so then what we have in mind is that Abby notices, that such and such in the formula looks a little suspicious, and she changes it, to something else to see what's going to happen. Then we ask the evaluators in the room, will Abby do this? Yes, no, maybe, and why? And some people might say yes because of Abby's task motivations, and other people would say no because of her comprehensive information processing style. And I personally would be on the side of the no's when evaluating this, because Abby doesn't want to start fiddling right away. Abby wants a lot more of a view of these formulas before she starts fiddling. We write them all down because the process itself is inclusive too. All opinions matter. We write them all down, and then after we've gotten everybody's opinion based on her cognitive styles, then we make Abby do what the developers wanted her to do. Even if she wouldn't before, we make her do it so that we can continue the evaluation. So, okay, she changes it to an 8, hits return, and sees the feedback, and then we say, will Abby feel like she's making progress toward her goal? Yes, no, maybe, and why? And again, we go back to the facets and so on and so forth. So these notes that we're taking along the way, these are becoming our Inclusivity Bug Report. So at the end of the day, what we've got is a list of the particular features at the particular stage of the program, what the screen looked like, and everything if we're using the note-taking tool that can come with it, so that people can then put it through triage, add it to their bug reports at whatever priority levels they feel like assigning, and decide what to do about it.
So I totally believe that you can do this as an expert in all of these styles, but imagine a regular software team that might consist of many people, as you said, that are male and from good universities, middle class. Is it hard to learn to evaluate these styles if they are very distinct from what your own personal style might be? How do you learn to do that as well as you do?
Yeah, yes, no, maybe is the answer to your question. Some people are very strong at putting themselves into other people's shoes and are really good at empathy. So some people just fall right into it. Some people are not as good at it, but they're reasonable at it. And some people have much more trouble, but those people are rare. But the things that we do to try to make this easy for anybody with no background is that we always have the persona in front of them throughout the entire time. If it's on one page, has bullet points and underlines and boldface so that people can see exactly what matters in this analysis. And then we measure how well people do. And so what we've found is that Gendermag boasts a very high true positive rate. And part of this is because of its heritage from the cognitive walkthrough, which is part of what it's derived from. So like other members of the cognitive walkthrough family, Gendermag's true positive rate is at least 95%. So put another way, the false positive rate is extremely low. And so what that says is, if people say something's going to go wrong for Abby, and then you do empirical studies, it will go wrong for somebody. Not necessarily everybody, but somebody. And that's, of course, what inclusivity is all about. On the other hand, if you have somebody that's not as good at putting themselves into Abby's shoes, you'll suffer from false negatives, people not noticing bugs that could have occurred. So if you find something, whether you're good at it or bad at it, it'll probably happen to somebody. That you can trust. But expertise is the thing that makes the difference on the false negative rate. In other words, your completeness of finding everything.
So I think I've understood how Gendermag can help in finding issues, because it helps you to put yourself in someone else's shoes, and though someone else is very well defined, this is how they look like and this is how they work. But how does it help in fixing issues? Okay,
Right.
now I know my software is not good for people that have comprehensive style. Now what do I do?
Right. Okay. Excellent question. So we've just started research in this area over the past year, and we got a paper out about it, which was some work we actually did in collaboration with Microsoft. And so the key is when you're doing your inclusivity bug report, when you're taking these notes, to be sure to write down the facet that caused you to solve it, to find it. And by this I mean the cognitive style. So when we were going through the spreadsheet example, we said Abby's going to be frustrated at this point because of her comprehensive information processing style. She wants more information. So on the report form that we give you, there's a checkbox, and so you would check off information processing style. So then when you're trying to figure out, well, how do I fix this, you start with the facet. Okay, and so yeah, the Abbeys did not like doing it this way at all. Why? Information processing style. They wanted more information. And so this is just pointing you at the doorway. Find a way to let them get more information. So it's not necessarily saying, do this 4-pixel change, but it's definitely pointing you into the thought process you need to have to fix it.
Yeah, so it's not something like a linter you could do over your code that says, oh, you should just add one enter here or one closing bracket and then it's all fixed.
Right.
But it's definitely helping you to understand what way you should look for the answer.
That's right. Yeah, I wouldn't exactly, it's sort of like you'll fall into these patterns. So the facets actually point you a lot to these patterns. And so one pattern is they need more information here, or they need more incremental ways to get information over there. So it's kind of so we need to think about information presentation here. Another really common one that arises with both risk and self-efficacy is vocabulary. This is a huge issue. Developers are always changing vocabulary at different points on an interface. Sometimes it's because it was developed by different people. And so, in one place something's called compose and somewhere else it's called new message. And so risk-averse people especially think, well, this isn't the thing I thought I was getting into. I must have hit the wrong button, or I must be going down the wrong path. And so a lot of times it's just labeling. And so if you say risk averse, they didn't think they were doing compose, they thought they were doing new. Now they're looking around for where's new. Okay, so once you think about that risk, it's because the labeling was wrong, you start thinking about, so we need to make sure that we're just being really consistent, because that's going to really help with risk averse people.
I guess that would help everyone. Consistent naming.
Exactly. And that's the thing. We've found this over and over again. When we find inclusivity bugs and we take them down one at a time in this way, it makes the software better for everyone. So it's not just benefiting the people that you found, it's benefiting everyone. And in fact, our most recent paper shows exactly that. In that particular paper with our Microsoft colleagues, we analyzed a particular piece of Microsoft software. In the before Gendermag version of that software, women failed the empirical tasks we gave them more than twice as often as the men. In the after version of the software, the gender gap completely disappeared and everybody got better.
Wow.
Yeah. It's such an awesome graph.
Yes. We'll definitely link to that paper. And actually, one of the questions I still have was, aren't things often a trade-off that if we make it better for one group, then we might make it worse for another group? But what you're actually saying in answering this question that I didn't ask is that that's not the case.
It's
that
not the case.
Fixing these barriers is just making sure the software allows for customization, for different ways of using it, so it wouldn't be to the detriment of people that are already using it in a good way.
That's right. Yeah, that's exactly right. It's not about trade-offs. It's about taking down inclusivity bugs.
That's happy news.
Yeah.
So one of my future shows is actually going to be about tech interviews. How do we interview developers and hire developers? And now I'm thinking, is this something where Gendermag could also be applied to things that aren't software but very related to software engineering? Because now I'm thinking of interviews are very much tech as a toy, like, let's implement the linked list, and people be like, oh, I'm so excited about this. But people that are very goal driven, they might wonder, why are we doing this linked list? What are we sorting? Where is this needed for? So do you think tech interviews also suffer from this bias, and could Gendermag be a solution there?
It's an interesting question. Yes, I definitely think it suffers from these kinds of biases. And in fact, I know that there are some people who have actually researched that and looked for the kinds of gender biases and other kinds of biases that are embedded in tech interviews. But can Gendermag help with that particular process? I'm not entirely sure. It would never do any harm. So perhaps you could find some things. But I think because of the particular 5 facets that we chose to focus on to keep the method small and viable, we're probably missing some of the facets that are really important when you're talking about interviewing. So it wouldn't hurt, but it probably wouldn't be a panacea for that one.
Yeah, so maybe another method should be needed that looks at the at risk and motivation, but not very much. Information gathering style wouldn't necessarily be very valuable in interviews.
Probably not enough of it. I mean, for example, there's some research that talks about some people being much more comfortable sort of standing up and doing stuff on the whiteboard, and other people that being like bringing out their very worst, whereas in reality they'd be awesome software developers, but they rarely do software development as a job on a whiteboard. And so you're not really measuring the thing that's really important in the job with that style of interview.
Yeah.
So there's a ton of research on that, and I think there's even a really recent paper on it, but I can't remember who it's from. I think it might, Andy Bagel may be one of the authors. There's also research on particular word choice that has many gender differences in what it brings out in people, and so lots and lots and lots of stuff out there that's applicable to interviews.
Yeah, we'll make sure we add some links to the show notes.
Okay.
So far we've mainly talked about how people use software in different ways with their different styles, but I also want to spend a little bit of time on how people create software, because many of the things we talked about for using software, like using a spreadsheet, is also true for if people are programming.
Yes.
So can you talk a little bit about how we could use Gendermag also as a means of understanding how people program rather than how they use software?
Yeah, so I haven't looked at the process of creating programs, but I have looked a great deal at debugging and other kinds of related software development tasks. And we see exactly the same thing that I've already described with, say, for example, spreadsheets, because just as you pointed out, it's problem solving. And just as in all the other situations, it's problem solving with tools. And so the tools, of course, are also software, and so that's the software that they're using, and it has the same biases as the software that's being created probably has. So it's exactly the same thing.
So you think if we have people in the audience that are developing tools for programmers, like IDEs or programming languages or libraries, that they're too using the Gendermag personas could be a very valuable way of understanding, hey, my API, how do different people with different cognitive styles use my software and create with that software.
Exactly, and some of the studies that we've done have been specifically in the realm of programming and programming environments, and we have found exactly those things.
It's interesting, I think, because I think for many people in software development, they see creating a program and using a program as really different things. Creating a program is creativity and shaping something, and using a program is following the rules of that specific program. So it's kind of interesting that you see the same patterns over things we see very, very differently.
Right, because it all involves problem solving. I mean, it's all about information gathering and about whether you want to try this thing or that thing. And so, everybody is a software user, even if they're creating a program.
So what about another potential use case of Gendermag that I was talking about, which is education, especially programming education? There you might also see that some type of exercises are very much meant for people that like an iterative style or they like a comprehensive style, but it's really different again from using software. So do you see value in using Gendermag to evaluate a course or a curriculum or an assignment or an exam?
Probably not if these things are paper or curricula, paper exams, that sort of thing. There are gender differences that have been shown in those kinds of things, but not the sort of thing that Gendermag would be able to detect. It would require different methods. But as soon as you put them on a platform, now you're back to people using software.
Yeah.
And so education software is indeed one of the offenders. There are all these gender differences that are overlooked, and gender biases, cognitive biases that are built into those things, same as all the other software.
Yeah. Yeah, not necessarily even just using the software, but also the type of assignments you have people solve and the type of style you encourage in solving those problems. If you say in a lecture, I'm now thinking of how guilty I am of this in my lecture, saying, it's always a very good idea to make small changes and then quickly see if you're on the right path. I'm like, I am also encouraging a certain style, and I might not be inclusive enough for people with a different style. So even something that's not really necessarily students behind the computer, I can imagine now after having done this episode, that in teaching, I will also think of these different styles that I didn't think of before.
Very good. Yes, that's awesome to hear.
Yeah, well, which might also be true, now I'm thinking of this, with documentation, which is also a form of education, of course. That also documentation is not necessarily people doing programming, but if the manual says, just make a little change and see where it leads, or you just, as we often say in programming, here's my awesome API and here's one example, and you can just try out the rest.
Exactly.
Like, if you're very risk averse, then maybe that's not a good style.
And in fact, that's one of the things that Anita Sarma is trying to investigate right now. So she's already got some momentum going on looking at documentation and how Gendermag can help find exactly that kind of problem.
Yeah, actually, the final thing I wanted to talk about this show is Anita Sarma's work about women and open source.
Yes.
Because also working in open source might encourage different people with different styles to participate at a higher rate.
Yes.
So can you share a little bit about that work and the direction that you're taking that in?
Yes. And so here again, this is Anita's specialty, but I will summarize it very briefly. So as I'm sure most of our listeners know, women are, of course, vastly underrepresented in computer science, but even more underrepresented in open source. So it's not the same level of underrepresentation. It's much, much worse in open source. And so there's been recent research trying to figure out why. But most of the recent research has focused on sort of the social climate in open source. But what we've recently started doing, led by Anita, is say, well, what about the open source toolware, the technical infrastructure? I mean, that's software, right? And open source contributors need to use that software, right? So here they are, software users trying to contribute to open source. And so our first paper on that came out in ICSI 2018, together with Igor Steinmacher and Marco Gerosa and some other co-authors as well. And what that showed is there was a very high rate of gender biases that open source developers found in open source tools they were using. So we didn't find them. The open source developers found them using the Gendermag method.
And then what type of tools are you talking about? I'm thinking GitHub is a tool where open source people collaborate with.
Right. And some of it included some documentation as well, the licensing agreements and this sort of thing. And then what we did is we verified it against some newcomer diaries, and we discovered that the kinds of barriers they were running into were exactly the ones that the open source developers had discovered using Gendermag. So we're still working on a journal paper to put all the details of that out there, but the conference paper is out there as an ICSI 18 paper.
Yeah, we'll definitely link to that, because of course it's very interesting that getting people in open source is a way to also fix issues with the thing that people are working on. So it has like this multiplier effect. So I think that's very interesting work. So if you can just give a few tips to our audience, because many people work on open source projects, we know that. What can people do to make it easier for women to contribute?
Well, the first thing they can do is use Gendermag to evaluate their own infrastructure, what it is that they expect people to make their way through. So not only are we talking about things like GitHub, but they have web pages, which are, which they have put up, the owners of that particular open source community, that describe things, provide readmes and things like that. And so they can look at, are we even giving people what they need to onboard, or are these really all, like the perfect things for people who already know everything.
Yeah.
So Gendermag can really help them just find stuff like that.
Yeah. So even again, looking at a README is broader than people using software. I'm also now thinking if you're very risk averse and the first thing you're like, oh, you just paste this line into the terminal, like npm, and name of the package. You're like, oh, maybe I shouldn't do that. Maybe I don't know what I'm downloading. This could be scary.
Exactly. And especially in these days of so much of these hacking and phishing and various kinds of security attacks, people have to be very mindful about what they go ahead and download. And so the more risk-averse people will be even more mindful of those kinds of things, which is not about being overly timid.
No, it's probably a good thing.
It probably is a good thing.
Not just to copy-paste source code from a random README file. Oh, just download a bunch of things on your machine.
Right, exactly.
Yeah, interesting. So that's all I wanted to ask. Thank you so much for being on the show. Is there anything that we missed? Anything I didn't ask that you still want to share?
I guess that we have a Gendermag Teach project. So there are faculty who are starting to integrate teaching of Gendermag into their computer science courseware. And so if you go to our main website, which is gendermag.org, it has a link for CS faculty, and at that link you'll see who else is teaching various bits and pieces of Gendermag. You'll find some lectures on, so you don't have to teach the whole method, you can teach one piece or another. You'll see some homework assignments, some test questions, just things that the community who have started using this in their classes have contributed. And if you do, let us know that you're teaching it so we can add you to the list so that other people in the community will know about you. And please feel free to contribute something back that you've changed or added to your own course so that we can, of course, give you credit and share it with others in the community.
Thanks. I think that's a really good resource, not just for people in education, but also for people in open source projects or within companies. If they want to explain this method to other people, then that could be materials they could use.
Yeah.
So we have lots of links that I will all add to the show notes. We have the gendermag.org website. Is there any other place where people can read about this on the internet?
Well, another good place to find stuff is on my own page. I have most of the papers I've written hanging off my homepage, so that is another way to get started. And we have some videos and blogs and stuff out there too that they can get to from my page or from the gendermag.org page.
Cool. We will link to all of those. Thank you so much for being on the show, Margaret.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.